Hello friends, in this video I'd like to solve the following problem from the Flanders Mathematics Olympiad 1989, problem number 4. Let n be a positive integer and let f be a function from the set of positive real numbers without 1 into the set of real numbers such that two conditions are satisfied. First, x to the power of n times f of x equals f of x squared for all positive numbers without 1, and also f of x equals x to the power of n for x's between 0 and 1 over 1989 union 1989 plus infinity. We wish to prove that f of x equals x to the power of n for all positive real numbers, x not equal 1. So it's a rather simple problem. Here are my hints. First, notice that if x is a positive number but is not equal 1, then x raised to a very high power is either going to be very close to 0 or close to plus infinity for sufficiently large positive integer k. Moreover, you should take the first condition and iterate it. So f of x equals x to the power minus n f of x squared, but f of x squared can be replaced by the same condition to this, and so on and so on. And also, remember that the sum of powers of 2, 1 plus 2 plus 4 and so on, plus 2 to the power k minus 1, is the next power of 2, but minus 1. So give this problem a try, and I will see you in just a minute. Right, so let's see. First, notice let x be a positive real number without 1. Then it is obviously true that x to the power 2 to the power of k is going to be, as I said, in this interval or in this interval or some sufficiently large positive integer k. Alright, and now I will be using my first condition over and over again, because f of x can be written as x to the power minus n f of x squared, but f of x squared can be written as x to the power minus 2n f of x to the fourth power. That in turn can be replaced by x to the power minus 4n f of x to the 8th power, and so on and so on and so on. In the end, we can go as far as we want, but I wish to go to the power minus 2 to the power k minus 1x, n rather, f of x to the power 2 to the power of k. Alright. Now, let's notice a few things. First, I can write x to the power minus n, and in the parentheses I will have 1 plus 2 plus 4 powers of 2 up to 2 to the power k minus 1. And this part right here, f of x to the power 2 to the power of k, well, I know that this number is in my union of intervals, so by condition number 2, it's x to the power of n. It can be it's the argument to the power of n. So I can take my argument and raise it to the power of n. Alright, and now let's take a look. Here I have x to the power minus n, and this expression in the yellow parentheses can be replaced by 2 to the power of k minus 1. And here I have x 2 to the power of k times n. And now, if I add these exponents, I will get just x to the power of n. And that closes our proof, because I have demonstrated now that f of x equals x to the power of n. So now we know that for every positive real number but not 1, f of x equals x to the power of n, which is exactly what we wanted. And that closes our problem. Thank you very much for watching. I will see you next time. Goodbye.